Tonight, as you settle into comfort and let your breathing slow, imagine for a moment that you could step outside, not just your room, but outside the very atmosphere of Earth itself. Picture yourself floating gently in the peaceful darkness of space, looking back at our beautiful blue world, spinning slowly beneath you. From this cosmic vantage point, you're about to begin a journey through the most intimate neighborhood in the universe, our solar system. As you drift in this imagined space, notice how Earth isn't alone in the cosmic dark. Stretching out around you in an elegant, invisible dance, 8 other worlds trace their eternal paths around the golden fire we call the sun. This is your cosmic family, a collection of worlds so diverse and wondrous that each one tells a different story about what it means to be a planet. Our solar system is like a vast, slow-motion waltz, choreographed by gravity itself. At the center, our sun, a star so perfectly ordinary and yet so essential, holds court as the gravitational conductor of this celestial orchestra. Its warm light has been the heartbeat of our cosmic neighborhood for over 4.5 billion years, providing the energy that makes life on Earth not just possible, but flourishing. Think of our solar system as a cosmic clock, its planets like hands moving at different speeds around the face of time. Mercury, closest to our sun, races around its orbit in just 88 Earth days, while distant Neptune takes 165 Earth years to complete a single journey. Yet each world moves with perfect precision, locked in gravitational harmony that has persisted since the solar system's birth. From your peaceful floating perspective, you can sense the invisible threads of gravity connecting everything. Planets to sun, moons to planets, asteroid to asteroid. These aren't cold mechanical forces, but the gentle cosmic glue that keeps our neighborhood together, allowing worlds to exist in stable orbits where they can develop their own unique personalities over billions of years. Our solar system spans nearly 6 billion miles from the Sun to Neptune, yet in cosmic terms, it's remarkably cozy. All of this celestial architecture could fit comfortably inside a sphere less than 12 light hours across. A tiny bubble of solar influence floating through the Milky Way galaxy like a ship carrying precious cargo through an infinite ocean. As you rest tonight, you're traveling through space at thousands of miles per hour, riding aboard Earth as it journeys around the sun. You're part of this cosmic dance, a passenger on a world that knows exactly where it's going, following a path worn smooth by billions of years of practice. There's something deeply comforting in knowing that you belong to this ancient, reliable system of worlds. Each planet in our solar system is like a different room in an enormous cosmic house, each with its own character, its own weather, its own unique way of interacting with the sun's light. Some rooms are scorching hot, others freezing cold. Some have thick, cloudy atmospheres like heavy curtains, while others are bare and exposed. Some rooms have many smaller companions, moons that dance around them like children playing in a garden. What makes our solar system truly special isn't just its mechanical precision, but the story it tells about possibility. Here, in this one small corner of the galaxy, we find worlds of ice and fire, storms larger than entire planets, rings of cosmic jewelry, and, perhaps most miraculous of all, at least one world where liquid water has flowed for billions of years, creating the conditions for life to emerge, evolve, and eventually gaze back out at the cosmos in wonder. Tonight, as sleep begins to call to you. Let yourself feel the gentle motion of Earth carrying you safely through the darkness. You're traveling aboard a world that has been practicing this same journey for over 4 billion years, never missing a step, never losing its way. In this cosmic clockwork, you can find a deep sense of belonging and peace. The inner worlds, Mercury, Venus, and Mars, as Earth's siblings. As your journey continues outward from Earth, you encounter the 3 worlds that are our planet's closest siblings, Mercury, Venus, and Mars. These are the terrestrial planets, rocky worlds forged in the same cosmic furnace as Earth, yet each has evolved along a dramatically different path. Like members of the same family who grew up to lead completely different lives, these worlds show us how many ways a planet can unfold its story. Mercury, the sun's swift messenger, races closest to our star in an endless game of cosmic tag. This small world experiences the most extreme temperature swings in the solar system, its surface blazing hot enough to melt lead during its day, then plunging to hundreds of degrees below freezing during its night. Mercury spins so slowly that one day on its surface lasts 2 of its years, creating a dreamlike world where the sun would appear to rise, set, rise again, then finally set during a single Mercurian day. Imagine standing on Mercury's surface, if you could, during the brief twilight between its scorching day and bitter night. The sun would hang enormous in the sky, 3 times larger than it appears from Earth. The horizon would be sharp and clear with no atmosphere to soften it, and the sky would be black even in daylight, scattered with stars. This is a world of extremes, a place where the very rocks flow like water under the intense solar radiation, then freeze solid in the darkness. Venus, Earth's mysterious twin, wraps herself in clouds so thick and toxic that they hide her surface completely from view. Beneath her beautiful pearl-white exterior lies a world that would be utterly alien to earthly life. The atmospheric pressure on Venus's surface equals that found 3,000 feet underwater on Earth, and her carbon dioxide atmosphere creates a greenhouse effect so intense that her surface temperature reaches nearly 900 degrees Fahrenheit, hot enough to melt copper. Yet Venus holds secrets that speak to Earth's own story. Beneath her crushing atmosphere lies evidence of what might once have been oceans, river valleys, and perhaps even a climate not unlike Earth's own. Venus shows us what can happen when a greenhouse effect runs wild, transforming a potentially habitable world into a cosmic cautionary tale. Her clouds contain sulfuric acid that falls as rain, but evaporates before reaching the ground, creating ghost storms in her perpetual twilight. The winds on Venus blow at hurricane speeds, yet at her surface, the thick atmosphere moves like thick honey, making her one of the calmest places in the solar system at ground level. It's a world of beautiful contradictions. Violent storms above, stillness below. Scorching temperatures under eternal clouds that block out the sun. Mars, the red wanderer, calls to us across space with a familiar, almost earthly voice. This rusty world, half Earth's size, bears the scars and stories of a planet that once knew flowing water, changing seasons, and possibly even life itself. Mars rotates at almost exactly the same rate as Earth, giving it days that feel familiar, and it tilts at nearly the same angle, creating seasons that last roughly twice as long as our own. Looking at Mars through a telescope from your comfortable position in space, You can see the white polar ice caps that grow and shrink with the Martian seasons, just as Earth's do. You might catch sight of dust storms that can engulf the entire planet for months, turning the Martian sky from its normal butterscotch color to deep red-brown. These planet-wide storms are gentle compared to Earth's hurricanes. The thin Martian atmosphere can't generate the powerful winds we know, but they can last far longer, sometimes covering the entire world in a rusty haze. Mars holds the most tantalizing hints of life beyond Earth. Ancient riverbeds carved into its surface tell of a time when liquid water flowed freely across Martian plains. Seasonal changes in its atmosphere suggest that something might still be stirring beneath its surface today. The planet's largest volcano, Olympus Mons, rises 3 times higher than Mount Everest, while its Great Canyon, Valles Marineris, could stretch across the entire United States. These 3 worlds, Mercury the swift and extreme, Venus the beautiful and deadly, Mars the familiar and mysterious, are Earth's planetary siblings. Each one illuminates something different about our own world's story. Mercury shows us what happens when a world lives too close to its star. Venus reveals the dangers of atmospheric extremes. Mars whispers hints of what Earth might have been like in its youth, or what it might become in its distant future. As you drift peacefully in your imagined space, consider how Earth found the perfect balance among its siblings. Not too close to the sun like Mercury, not trapped in runaway greenhouse warming like Venus, not too small to hold on to its atmosphere and water like Mars. Earth found the sweet spot, the cosmic Goldilocks zone, where liquid water could exist, where life could take root and flourish. Tonight, as you rest on our perfectly balanced world, you can appreciate how special it is to live in a place where the temperature is just right, where water flows and rain falls gently, where the atmosphere is neither too thick nor too thin, but perfectly suited for breathing, for weather, for life itself. Earth didn't just happen to be perfect. It grew into its perfection over billions of years, finding its balance in the cosmic dance. The giant dancers, Jupiter and Saturn's majestic realms. Beyond Mars lies a different realm entirely, where the solar system reveals its most majestic and powerful inhabitants. Here, in the outer reaches of our cosmic neighborhood, giant worlds dance through space with such grace and gravity that they have shaped the very architecture of our entire solar system. Jupiter and Saturn, the 2 largest planets, are not just worlds but cosmic sculptors, their immense gravitational influence having guided the formation and evolution of everything around them. Jupiter, the king of planets, reigns as a world so large that it could contain all the other planets of our solar system with room to spare. This giant world is what astronomers call a failed star. If Jupiter had been perhaps 50 times more massive, nuclear fusion would have ignited in its core, and our solar system would have had 2 suns instead of 1. Instead, Jupiter became something equally magnificent, the solar system's gentle giant and protector. As you float peacefully in your cosmic vantage point, imagine approaching Jupiter's swirling atmosphere. This is a world with no solid surface as we know it. Instead, its thick atmosphere gradually becomes so compressed that it transitions into liquid, then into exotic forms of matter that exist nowhere on Earth. Jupiter's famous Great Red Spot, a storm larger than our entire planet, has been raging for centuries, possibly millennia. It's a hurricane that could swallow Earth whole, yet it represents just one feature in Jupiter's constantly shifting tapestry of colored bands and swirling clouds. Jupiter's atmosphere moves in distinct bands around the planet, like cosmic rivers flowing at different speeds. These bands create zones of rising and falling gases that paint the planet in shades of tan, brown, red, and cream. The colors come from different chemical compounds lifted up from Jupiter's interior. Sulfur creating yellows and browns, phosphorus adding reds, and ammonia crystals providing the whites and creams. It's as if Jupiter is a living painting, constantly recreating itself in new patterns and hues. But Jupiter's most important role in our solar system might be as Earth's cosmic bodyguard. Its immense gravity acts like a celestial vacuum cleaner, capturing comets and asteroids that might otherwise threaten the inner planets. Many scientists believe that without Jupiter's protective influence, Earth might have been struck by devastating impacts far more frequently, making the evolution of complex life much more difficult, or perhaps impossible. Jupiter doesn't dance alone through the outer solar system. It's accompanied by at least 79 moons, 4 of which are large enough to be considered worlds in their own right. Io, the most volcanically active body in the solar system, is constantly being kneaded by Jupiter's gravity until its interior melts and erupts in spectacular fashion. Europa hides a vast ocean beneath its icy shell, an ocean that contains more water than all of Earth's oceans combined. Ganymede, larger than the planet Mercury, may also harbor a subsurface ocean. And Callisto, ancient and cratered, preserves the history of the solar system's violent early days. Saturn, the second giant, brings its own magic to the outer solar system in the form of the most spectacular ring system known. From your peaceful floating perspective, Saturn's rings would appear as impossibly thin sheets of ice and rock, so delicate they seem like cosmic spun glass, yet spanning a distance greater than the space between Earth and its moon. These rings are not solid structures, but countless individual particles, each one a tiny moon following its own orbit around Saturn. Some particles are as small as dust grains, others as large as houses, all dancing together in gravitational harmony. The rings are surprisingly thin. In some places, they're only about 30 feet thick, making them proportionally thinner than a sheet of paper compared to their width. Saturn itself is a world of wonders that rival even Jupiter's majesty. This golden giant spins so fast that it bulges noticeably at its equator, and its density is so low that it would actually float if you could find an ocean large enough to hold it. Saturn's atmosphere generates winds that blow at over 1,100 miles per hour, far faster than any hurricane on Earth. Yet these supersonic winds blow in perfect geometric patterns around the planet. At Saturn's North Pole lies one of the most mysterious features in the solar system, a perfect hexagon of clouds, each side larger than Earth's diameter. This six-sided storm has maintained its shape for decades, a geometric pattern that seems almost too precise to be natural. Yet there it spins, in Saturn's golden atmosphere, like a cosmic snowflake. Saturn's largest moon, Titan, presents perhaps the most Earth-like world beyond our own planet. though its version of familiar processes uses entirely different materials. Titan has lakes and rivers, clouds and rain, even seasonal weather patterns. But instead of water, Titan's hydrological cycle uses liquid methane and ethane. Its thick, hazy atmosphere gives it a surface pressure similar to Earth's, and its lakes of liquid hydrocarbons create shorelines that might seem almost familiar to an earthbound observer. Both Jupiter and Saturn generate more heat than they receive from the Sun, slowly releasing the energy left over from their formation billions of years ago. They're like cosmic hand warmers, still gently glowing with the memory of their birth. This internal heat powers their dynamic atmospheres and helps warm their many moons, creating the conditions necessary for liquid water to exist in the hidden oceans beneath icy surfaces. As you rest tonight, consider the gentle giants that share our solar system neighborhood. Jupiter and Saturn dance through space with such massive grace that they create stability for all the smaller worlds. Their gravitational influence helps maintain the orderly spacing of planetary orbits, and their magnetic fields deflect harmful cosmic radiation that might otherwise strip away the atmospheres of the inner planets. These gas giants remind us that worlds can be built in many different ways. While Earth and its rocky siblings formed from metals and stone, Jupiter and Saturn grew by accumulating vast amounts of hydrogen and helium gas, becoming more like miniature solar systems than single worlds. Each giant planet, with its retinue of moons, creates its own ecosystem of gravitational relationships and orbital dances. Tonight, as you drift toward sleep, you can imagine the giant dancers continuing their ancient waltz through the outer solar system, their massive presence creating the stable, protected environment that allows smaller worlds like Earth to exist in peace. In the grand choreography of our cosmic neighborhood, even the largest performers dance with perfect gentleness. The ice worlds: Uranus, Neptune, and the outer mysteries. As your journey carries you beyond the realm of the gas giants, you enter the mysterious outer reaches of our solar system, where two ice giants patrol the cold frontier of our cosmic neighborhood. Uranus and Neptune, along with their exotic moons, represent some of the strangest and most beautiful worlds in our solar family, places where familiar physics creates utterly alien landscapes, and where the search for life has led to some of the most exciting discoveries in astronomy. Uranus, the sideways world, presents one of the solar system's most puzzling mysteries. Unlike every other planet, Uranus rolls through space on its side, tilted at an angle of 98 degrees. This means that for 42 years at a time, one of its poles points directly toward the sun, while the other remains in darkness. Then, as Uranus continues its 84-year journey around the sun, the seasons gradually shift until the opposite pole enjoys its long summer, while the first pole endures an equally long winter. Imagine the strange beauty of seasons on Uranus, not the familiar cycle of months that we know on Earth, but seasons that last for decades. A person born during northern summer on Uranus wouldn't see the sun rise at the South Pole until they were middle-aged. It's a world where the very concept of day and night takes on an entirely different meaning, where the aurora displays might dance constantly around one pole for 20 years, then gradually shift to the other side of the planet. Uranus appears as a serene blue-green world, colored by methane in its atmosphere that absorbs red light and reflects blue and green wavelengths back to space. But this peaceful appearance hides a dynamic interior unlike any other world we know. While Jupiter and Saturn are made primarily of hydrogen and helium, Uranus consists largely of water, methane, and ammonia ices surrounding a rocky core. It's not quite a gas giant, and not quite a terrestrial planet, but something uniquely its own. The magnetic field of Uranus adds another layer to its mystery. Instead of aligning roughly with the planet's rotation like Earth's magnetic field, Uranus's magnetic field is tilted at 59 degrees to its rotational axis and offset from the planet's center. As Uranus rotates, its magnetic field wobbles through space like a cosmic corkscrew, creating one of the most unusual magnetospheres in the solar system. Neptune, the deep blue wanderer at the edge of our solar system, holds the distinction of being the windiest world we know. Despite receiving only 1,000th the sunlight that Earth does, Neptune generates winds that scream across its surface at speeds of up to 1,200 miles per hour, faster than the speed of sound on Earth. These supersonic winds remain one of the great puzzles of planetary science, powered by some internal energy source that we don't yet fully understand. Neptune's deep blue color comes from methane in its atmosphere, but the planet is slightly bluer than Uranus, despite having similar atmospheric composition, suggesting some unknown component contributes to its striking azure hue. Dark storm systems, some the size of Earth, race across Neptune's surface faster than any weather system on our planet. Yet they can persist for years before mysteriously dissipating. Like Uranus, Neptune generates more heat than it receives from the Sun, radiating 2.6 times as much energy as it absorbs. This internal heat source drives the planet's dynamic atmosphere and creates the energy that powers those incredible wind speeds. Neptune is like a cosmic engine, still running on the gravitational energy from its formation over 4 billion years ago. But perhaps the most exciting discoveries in the outer solar system have come from exploring the moons of these ice giants. Neptune's largest moon, Triton, presents one of the most intriguing worlds in our solar system. Triton orbits Neptune backwards compared to the planet's rotation, suggesting it was once a dwarf planet from the outer solar system that Neptune captured in its gravitational embrace. This icy world, with a surface temperature of -391 degrees Fahrenheit, still shows signs of geological activity. Triton's surface is covered in nitrogen frost and features dark streaks created by nitrogen geysers that erupt from beneath its frozen surface. These geysers shoot nitrogen gas and dark particles up to 5 miles high into Triton's thin atmosphere. The fact that such a cold world can still generate active geology suggests that tidal heating from Neptune's gravity keeps Triton's interior warm enough to drive these processes. The possibility of liquid water existing beneath the icy surfaces of outer solar system moons has revolutionized our understanding of where life might exist. Jupiter's moon Europa and Saturn's moon Enceladus have already shown strong evidence for subsurface oceans. But recent studies suggest that many icy moons throughout the outer solar system might harbor liquid water beneath their frozen shells. These hidden oceans could exist because of tidal heating, the gravitational flexing that occurs as moons orbit their parent planets in elliptical paths. Just as kneading bread dough generates heat through friction, the constant stretching and compressing of these moons by their planet's gravity generates enough heat to melt ice and maintain liquid water oceans for billions of years. The implications are profound. While the surface of these worlds might be frozen and seemingly lifeless, beneath the ice could exist vast oceans with more water than all of Earth's oceans combined. These hidden seas might have existed continuously for billions of years, providing stable environments where life could potentially evolve and thrive. From your peaceful vantage point in space, The ice worlds of the outer solar system might seem cold and forbidding, but they represent some of the most promising places to search for life beyond Earth. They remind us that life doesn't require Earth-like conditions to exist. It might flourish in environments that seem completely alien to our experience. As you drift towards sleep tonight, consider the beautiful irony that some of the coldest places in our solar system might actually be the most hospitable to life. Beneath shells of ice that never feel the sun's warmth, vast oceans might lap against rocky shores, driven by currents and warmed by the heat of planetary formation that still glows in these worlds' cores. The ice giants and their moons expand our definition of what it means to be habitable. They suggest that our solar system, and perhaps the galaxy beyond, might be filled with hidden oceans and secret worlds where life could exist in forms we're only beginning to imagine. In the cold depths of space, water still flows, geology still shapes worlds, and the possibility of life still beckons to us across the darkness. The timekeepers, asteroids, comets, and solar system history. Between and beyond the planets of our solar system drift the smaller members of our cosmic family. Countless asteroids, comets, and minor bodies that serve as libraries of our neighborhood's history. These seemingly humble objects are actually time capsules, preserving the original materials from which our solar system formed over 4.5 billion years ago. As you rest peacefully tonight, imagine these ancient wanderers carrying the stories of cosmic time through the darkness between worlds. The asteroid belt, stretching between Mars and Jupiter, might seem like a cosmic demolition zone, but it's actually a remarkably ordered and peaceful place. Despite science fiction portrayals of dense fields of tumbling rocks, the asteroid belt is mostly empty space. If you were piloting a spacecraft through it, you might travel for hours or days without seeing a single asteroid. The largest asteroid, Ceres, is now classified as a dwarf planet and contains about 1/3 of the belt's total mass, while hundreds of thousands of smaller bodies trace their own orderly orbits around the Sun. These asteroids are fragments of planetesimals, the building blocks from which planets formed in the early solar system. The asteroid belt represents a world that never quite managed to come together. Jupiter's powerful gravity stirred up this region so vigorously that the rocky fragments never settled down long enough to accrete into a single planet. Instead, they remain scattered in their orbits like cosmic gravel, each piece a sample of the raw materials that built the terrestrial planets. Some asteroids are made of metal, iron, and nickel that would have formed the core of a planet if given the chance. Others are rocky, composed of the same silicate minerals that make up Earth's crust and mantle. Still others are rich in carbon and organic compounds, preserving the very molecules that may have served as the building blocks of life. Each asteroid type tells a different part of the story about how rocky planets form and evolve. When asteroids occasionally collide with Earth, they become meteorites, direct samples of other worlds that we can hold in our hands and study in laboratories. These cosmic messengers have taught us that organic compounds, including amino acids and other complex molecules, were common in the early solar system. Some scientists believe that asteroid impacts may have delivered the ingredients for life to early Earth, seeding our world with the chemical building blocks that eventually led to the first living organisms. Comets represent an even more ancient archive of solar system history. These
dirty snowballs formed in the frigid outer reaches of the solar system, where water, methane, ammonia, and carbon dioxide froze into solid ice mixed with dust and rocky particles. Comets are like cosmic fossils, preserving materials in deep freeze for billions of years, unchanged since the solar system's birth.
Most comets spend their time in two vast reservoirs at the edge of our solar system. The Kuiper Belt, beginning beyond Neptune's orbit, contains thousands of icy bodies, including the dwarf planet Pluto. Much farther out, the Oort cloud forms a spherical shell of dormant comets surrounding our entire solar system, at distances so great that the Sun appears merely as the brightest star in the sky. Occasionally, gravitational perturbations send comets falling inward toward the Sun. As they approach, solar radiation begins to vaporize their icy surfaces, creating the spectacular tails we see from Earth. A comet's tail doesn't trail behind it like the exhaust from a rocket. Instead, it always points away from the Sun, blown by the solar wind like a cosmic weather vane. Comets actually have two tails, one made of dust particles that curves gently along the comet's orbit, and another made of ionized gases that points straight away from the Sun like a cosmic arrow. The beauty of a comet's display belies the ancient story it tells. The water vapor and organic compounds streaming from its nucleus may be the same materials that condensed from the primordial solar nebula when our star system was just beginning to form. When we see a comet blazing across Earth's sky, we're witnessing the sublimation of materials older than any rock on Earth, pristine samples of the cosmic environment from which all the planets emerged. Recent spacecraft missions have revealed that comets are far more complex and active than we once imagined. They have seasons, as different parts of their surfaces face toward or away from the Sun. They can have their own weather systems, with jets of vapor creating temporary atmospheres. Some comets even have their own small moons, tiny companions that dance around the main nucleus as both objects journey through space together. The study of asteroids and comets has revolutionized our understanding of how the solar system formed and evolved. We now know that the early solar system was a much more dynamic and chaotic place than we once imagined. Planets migrated inward and outward from their original orbits, influenced by gravitational interactions with Jupiter and Saturn. This grand tack model suggests that Jupiter actually moved inward toward the Sun before reversing course and migrating outward, helping to sculpt the asteroid belt and influence the formation of the terrestrial planets. Asteroid impacts have played a crucial role in shaping planetary evolution. The Moon's heavily cratered surface preserves a record of the late heavy bombardment, a period about 3.9 billion years ago, when the inner solar system experienced a spike in impact activity. This bombardment may have been triggered by the migration of the giant planets, which disturbed the orbits of countless small bodies and sent them careening through the inner solar system. Paradoxically, while large impacts can be destructive to existing life, they may also have been essential for life's emergence on Earth. Impacts delivered water to our planet's surface and may have created the chemical conditions necessary for life to begin. The impact that killed the dinosaurs 66 million years ago also cleared ecological niches that allowed mammals, including our own ancestors, to diversify and flourish. As you rest tonight, these ancient timekeepers continue their patient orbits, carrying their precious cargo of primordial materials through the darkness. Every asteroid and comet is a messenger from the solar system's youth, preserving chemical and isotopic signatures that tell us about the conditions when planets were forming. and life was beginning. They remind us that we live in a solar system that is not static, but constantly evolving, shaped by billions of years of gravitational interactions, impacts, and orbital migrations. The small bodies of our solar system teach us humility and wonder. They show us that even the tiniest fragments of cosmic debris can preserve the most profound secrets about our origins. In their ancient ices and primordial rocks, we find the same elements and compounds that make up our own bodies, connecting us directly to the birth of our cosmic neighborhood and reminding us that we are quite literally made of star stuff, forged in the same processes that created all the worlds around us. The edge of home, Kuiper Belt, Oort cloud, and beyond. As your cosmic journey carries you beyond Neptune and toward the very frontier of our solar system, you enter a realm where our sun's influence grows dim and the vast emptiness between stars begins to assert itself. Yet even here, at the edge of everything we call home, remarkable worlds and phenomena await discovery. The Kuiper Belt, the Oort cloud, and the boundary between solar and interstellar space reveal the true scope of our cosmic neighborhood and our place in the greater galactic community. The Kuiper Belt begins just beyond Neptune's orbit and extends outward for billions of miles, a vast ring of icy bodies that represents the solar system's attic, a place where the leftover materials from planetary formation have been stored in cosmic cold storage for over 4 billion years. Here, in the dim light of a sun that appears merely as a bright star, dwarf planets and countless smaller objects follow their ancient orbits in the perpetual twilight of the outer solar system. Pluto, perhaps the most famous resident of the Kuiper Belt, embodies the exotic nature of these distant worlds. This dwarf planet, smaller than Earth's moon, maintains a complex dance with its largest moon, Charon. The two objects are so close in size that they orbit around a point in space between them, essentially forming a double planet system. Pluto's day and Charon's orbital period are perfectly synchronized, meaning that if you stood on one world, the other would appear to hang motionless in the sky, never rising or setting.
Pluto's surface reveals a world of surprising complexity and beauty. Its heart-shaped nitrogen plain, informally named Tombaugh Regio, showcases active geology driven by the slow sublimation and redeposition of nitrogen ice. Mountains of water ice, as hard as rock in the extreme cold, rise from plains of frozen nitrogen. The thin atmosphere contains layers of haze that create hauntingly beautiful sunsets where the distant sun appears as a bright point of light, surrounded by delicate blue atmospheric glow. Beyond Pluto lie numerous other Kuiper Belt objects, each with their own unique characteristics. Some, like the dwarf planet Eris, are even more distant than Pluto and may be covered in methane snow. Others have unusual shapes. Some appear to be contact binaries, two objects that slowly collided and stuck together, creating worlds that look like cosmic peanuts spinning through space. The New Horizons spacecraft, which visited Pluto in 2015, continued its journey deeper into the Kuiper Belt to encounter Arrokoth, a pristine remnant from the solar system's formation. This small, reddish object revealed itself to be remarkably smooth and gently sculpted, showing none of the violent cratering that marks objects in the inner solar system. Arrokoth represents the gentle, low-energy environment in which the outer solar system formed, where objects could come together through soft collisions rather than catastrophic impacts.
Far beyond the Kuiper Belt lies the Oort cloud, a vast spherical shell of dormant comets that extends nearly halfway to the nearest star. This invisible reservoir contains perhaps 1 trillion icy bodies, all weakly bound to our sun's gravity at distances so great that they barely feel its influence. The Oort cloud represents the true boundary of our solar system, the edge of the sun's gravitational dominion, and the beginning of interstellar space. Objects in the Oort cloud move so slowly in their orbits that they take millions of years to complete a single journey around the sun. These dormant comets are influenced not just by our sun's gravity, but by the gravitational perturbations of passing stars and the overall rotation of our galaxy. Occasionally, these external influences nudge an Oort cloud object inward, beginning its transformation into a long-period comet that will take thousands or millions of years to reach the inner solar system. The Voyager 1 spacecraft, launched in 1977, became humanity's first emissary to leave our solar system when it crossed into interstellar space in 2012. This remarkable achievement marked the beginning of our direct exploration of the space between stars. Voyager 1's instruments revealed that interstellar space is not empty, but filled with a thin soup of atoms and magnetic fields that differs dramatically from the environment within our solar system's influence. The boundary between solar and interstellar space, called the heliopause, is created by the solar wind, a stream of charged particles flowing outward from the sun, colliding with the interstellar medium. This creates a cosmic bubble called the heliosphere that surrounds our entire solar system like a protective cocoon. The heliosphere shields us from some of the high-energy cosmic rays that pervade interstellar space, creating a slightly more benign environment for the inner planets. Our entire solar system moves through the galaxy at approximately 230 kilometers per second, completing one orbit around the galactic center roughly every 225 million years. This galactic year is so long that the last time our solar system was in its current position relative to the galaxy's spiral arms, dinosaurs were just beginning to diversify on Earth. As we orbit the galaxy, we encounter different regions of interstellar space with varying densities of gas and dust, different magnetic field orientations, and different populations of nearby stars. Currently, our solar system is moving through a region called the local interstellar cloud, a relatively warm and thin region of space created by ancient supernova explosions. In about 10,000 to 20,000 years, we may enter a denser region that could compress our heliosphere and potentially affect the climate of the inner planets. These galactic influences remind us that even our protective solar system is not isolated, but constantly interacting with the larger cosmic environment. The edge of our solar system also represents the beginning of our search for other planetary systems. The nearest star to our Sun, Proxima Centauri, lies about 25,000 times farther from us than Neptune. Yet even this seemingly impossible distance is being explored by our instruments. We now know that Proxima Centauri has at least 2 planets, including one that orbits within its star's habitable zone, where liquid water could potentially exist. As you rest peacefully tonight, consider the profound perspective that comes from imagining yourself at the edge of our cosmic neighborhood. From this vantage point, our entire solar system, all the planets, moons, asteroids, and comets we've explored on this journey, would appear as a single point of light, indistinguishable from the countless other stars scattered across the galaxy. Yet within that single point of light lies everything we know and love. every human story, every living creature, every breath of air and drop of water. This perspective doesn't diminish Earth's importance, but rather highlights its preciousness. In the vast cosmic ocean of space and time, our solar system represents a remarkable oasis where complexity and beauty have flourished. The same gravitational forces that sculpted Jupiter's swirling storms and carved the channels on Mars also created the stable, protective environment that allowed life to emerge and evolve on Earth. The edge of our solar system is also a frontier of possibility. As our technology advances, humans may one day travel to these distant realms, perhaps establishing research stations in the Kuiper Belt, or using the outer planets as stepping stones to interstellar space. The same curiosity and ingenuity that allowed us to explore the inner planets and send spacecraft to Jupiter and Saturn will eventually carry us to these most distant corners of our cosmic home. Tonight, as sleep carries you into peaceful dreams, you can rest knowing that you belong to something vast and wonderful, a solar system that has been our cosmic cradle for billions of years.